Hey everyone, this is the next round of Exponent rules. I'm going to go through this pretty quickly, so feel free to pause it anytime you need to write these notes down. Just to be really clear, to start off, when we have an exponent here, x to the fifth power, the x, the bigger number, the lower number, is called our base. And the number that it's being raised to, that's actually the exponent. And that's going to come into play here. Understanding what the base is and being able to recognize what the base is of a certain exponent number. Okay, right into multiplying. Let's just get this rule down. May not make sense right off the bat, but with these example problems, they will. To multiply exponents with the same base, add the exponents together. So let's get that note down. Again, it might not make sense right off the bat, but we're going to do some example problems to demonstrate that idea. So here is our first expression, x to the third times x to the fourth. Now, this is obviously a multiplication problem. We want to simplify this expression down. We happen to have the same base. So when we have the same base, we can simplify. So this is going to become x, the base is going to stay the same. And I'm literally just going to add these exponents together, 3 plus 4. And I'm going to end up with x to the 7th. And that's literally it when it comes to multiplying exponents with the same base. The reason this works is if I were to expand this problem out, it would just look like x times x times x, x to the third power here, x times x times x, times x to the fourth power, 1, 2, 3, 4. I got 4 x's there. Well, with multiplication, order doesn't matter, so I can jumble all these around. This is like saying x times x times x. How many x's do I have? 1, 2, 3, 4, 5, 6, 7. This is the same as x to the 7th. So we can see why this rule of adding the exponents together works for multiplication. Let's do another one. We've got some negative numbers here, but we're just going to use our integer rules and figure it out. My base here is 2 to the negative fifth times 2 to the 7th. I have the same base. The base is 2. So the base stays the same. And then I'm just going to add the exponents together. Negative 5 plus 7. What's negative 5 plus 7? Positive 2. And that is my simplified version of this expression. We could even take it a step farther. 2 to the second power is 4. Now, when going a little bit further, when we start simplifying expressions that aren't so simple, we're going to start to see stuff like x to the fifth, y to the second, x to the third. That's going to be an expression that we need to simplify, these 3 terms. Well, there's nothing I can do with the y because it doesn't match the bases of the x's. But what I can do is combine these x's with the same base by just adding their exponents together. 5 plus 3 is 8. So this whole thing is going to reduce down to x to the 8th, and then the y to the 2nd is going to come along for the ride. I did not share a same base between the x and the y, so there's nothing I can do to combine this. Cool. Moving right along to dividing. Now, it would make sense that multiplying and dividing are opposite. So when we're dealing with the exponents, we're going to do the opposite. And that is true here. To divide exponents with the same base, again, same base is key, we're going to subtract the exponents. And our first example problem here, a division, x to the fifth divided by x squared. I have the same base, which is key, which is x. So there's x again right there. And this is literally going to become a subtraction problem. The numerator exponent minus the denominator exponent. So 5 minus 2. Again, I just did 5 minus 2. And that's going to be x to the third power. A reason why this rule works, same idea, if I expand this problem out, x to the fifth, that's 5x's, 1, 2, 3, 4, 5 in the numerator. I got 2 x's in the denominator, 1, 2. These x's are going to cancel each other out. That one's going to cancel that one out. That one's going to cancel that one out. What am I left with? 3 x's in the numerator, 1, 2, 3. That is the same as x to the third power. And last example problem. Y to the second power divided by y to the fourth power. My bases are the same. That's key. And this order counts here. I want to take the numerator exponent 2, and I want to subtract the denominator 4, the denominator exponent. 2 minus 4, well, that's negative 2. And this is a simplified version. We can take it a step further using our rules around negative exponents. And we know that we're going to throw, when we have a negative exponent, we're going to throw that in the denominator. And my exponent is going to turn positive, and 1 belongs in my numerator. So all this condenses down to 1 over y squared. And that's all I got for you guys for now. Thanks for watching.